Simon Wiseman, CTO at Deep Secure. Data diodes are a really easy way of protecting critical systems from attack, but their use prevents monitoring systems pulling production data when they need to. The use of protocol proxies can overcome this limitation, and I've set a demonstration up in the lab that shows you how. Come back and see how it works. By way of example, let's suppose we want to monitor the power output of a power station. The monitoring system would periodically make a connection to the control system at the power station, and it would send a request for the latest data. The control system would then return the requested data, and the monitoring system would display it. But what happens if a data diode is placed between the power station and the monitoring system to stop any cyber attacks disrupting the critical system? The monitoring system will try to connect to the data diode and send the request for information. But the data diode is blocking all data travelling in this direction, so the request is discarded and doesn't reach the power station. Consequently, the power station doesn't know that it needs to report its power output. To overcome this problem, we have to install proxies either side of the data diode. The proxy on the production side makes periodic connections to the power station control system and sends requests for information. The control system responds with the data. The proxy receives this and then pushes it through the data diode to the proxy on the monitoring side. This proxy stores the data until the monitoring system makes a connection to it and sends a request for the information. The proxy returns the data to the monitoring system, which can then display it. To demonstrate this, we have set up two servers to act as the proxies. The black netbook is on the production network and is periodically pulling production data from our simulated power station. The red netbook is on the monitoring network and serving the results through a web application to the laptop. At the moment, the two networks are directly connected, so a cyber attack could be launched from the monitoring network against the critical production network. This diagram shows the arrangement. The proxy on the production network is periodically pulling data from the power station control system. It pushes this data to the proxy on the monitoring network, and this proxy is running on the same server as the monitoring application, which serves up the data to the engineer's laptop through a web interface. Here you can see the display on the laptop. This simple web application is polling the monitoring server for the latest data, and you can see the values changing and the colours indicating the direction of travel. Now we are going to replace the direct connection between the two networks with a data diode. This will sit between the two proxies and allow the production side proxy to push data to the proxy on the monitoring network. Requests to pull data do not pass through the data diode and so are not discarded. We are going to use a Minerva data diode for this task, as it is simple and easy to install and configure, and we will be up and running in a few minutes. This is Deep Secure's next generation data diode. Minerva is an appliance that comprises two servers. Here we have mounted them together in a desktop rack, but they can fit in separate racks some distance apart if more separation is required. The two servers are joined by a one-way link made from optical fibre. Internal media converters in each server ensure that the connection is strictly one way, with no possibility of any data passing in the reverse direction. In our demonstration, data is pushed from one proxy to the other using HTTP. One server of the appliance acts as an HTTP server and receives data pushed to it from the proxy on the production network. The other server acts as an HTTP client, pushing data to the proxy on the monitoring network. Data received by the HTTP server is passed across the one-way fibre link using an internal protocol designed to provide performance and reliability. There is no reliance on TCP/IP here. Having connected up the Minerva appliance, we now need to configure each server. Let's start with the server on the production network, which is to act as the HTTP server. First, we connect using the default IP address and log in with the default username and password. The first thing we must do is change the IP address. We're going to select the same address as the monitoring system, so the proxy doesn't need to be reconfigured. Minerva can be set up to pass multiple data streams, but in this demonstration we're just going to set up one. All we need to do here is give it a name, in this case power. Now we have to create protocol handlers that will receive data and pass it to a channel. Our proxies are communicating using HTTP on port 80, so this is what we need to configure. Finally, we need to change the password, because Minerva won't start passing data while it is configured with the default password. Now we have to save our changes, and because the IP address has been changed, we have to reconnect the browser. After a moment, we can get back in using the new IP address and password. Now we must move to the production network and set up the Minerva server on that side. This one is to act as the HTTP client. As before, we connect using the default IP address and log in with the default username and password. Now we change the IP address, this time selecting the same address as the power station control system, so the proxy doesn't need to be reconfigured. Both servers have to be configured with the same list of channels. We set up just one channel called Power on the other server, so must do the same here. For each channel we have to specify how the data is to be delivered to its destination. We're using HTTP for this demo, and so we must specify the destination server IP address and the web server name. Having done that, we just need to change the password from its default value so Minerva will start passing data. We've now configured both servers so Minerva is up and running and data can pass from one proxy to the other. Looking at the user interface once more, we can see that production data is being displayed, despite the monitoring system being unable to pull it from the power station control systems directly. That's all there is to it. Minerva is easy to install and easy to integrate with applications. If you'd like to know more, give us a call.